Right, so today what we did last section, we did arithmetic with expressions involving radicals. So how do we add and subtract expressions with radicals? Well, we can add like radicals together. We can't add unlike radicals together. We did some multiplication of expressions involving radicals. None of that was too bad. Today we're going to look at dividing, if we divide expressions that have radicals in them. And we call this rationalizing denominators. We'll talk about why in just a second. So what about something like this? Okay, what's wrong with that? Well, in one sense, there's nothing wrong with that. I can't simplify the top or the bottom, and so sometimes we just leave fractions like that, but most of the time we don't. Most of the time, we don't like to have irrational numbers in the denominator. And if I have a square root of some radicand that's not a perfect square, for example. Square root of 2 doesn't go away. Square root of 2 is a random decimal that goes forever. It's irrational. And so we need to do a little algebra here to rewrite this number, this fraction, in a way where the denominator is no longer a square root. You have an idea? Multiply by 2 over 2? Close. No, so now, let's think about the things we can do here. If I put this in a calculator, would you guys all agree I'm just going to get some decimal answer, right? Do I want that decimal answer to change? No, I don't, right? I want to end up getting the same decimal answer when I'm done simplifying this, but I just want it to be written in a better way is all, right? So whatever I do, anything I do can't change the overall value. So what do you think I could do? If I square it, isn't that going to change the decimal answer though? Because if I have a decimal answer and I square it, doesn't that give me a different decimal? So I can't do that.
Are you wanting us to just rewrite it into a different looking way?
That's exactly what we're doing. But how are we going to get there? What's the step that's going to get us to a different way? Multiplication, yeah. What's the only number I can multiply by and not change the value of a number? 1. Right, so I've got to multiply by a fraction that's equal to 1. But think what that means. A fraction equal to 1 just means that the top and the bottom are the same. That makes the fraction equal to 1, right? Now what determines what goes on the top and the bottom is the square root of 2 on the bottom, because that's the problem child here, right? That's the thing we have to get rid of. What could I multiply the square root of 2 by to get rid of the square root? If I multiply the square root of 2, if I multiply that by 2, I'm just going to get 2 times the square root of 2. No. What would I need to get inside the radical in order for that square root to go away? Say it again? No. Think about this now. We have a square root here, right? You guys are overthinking this a little bit. It's going to click in just a second. But if I have a square root, we have a saying, what goes out? How big a groups do I need to go out? Couples, right? So right now, inside the square root, I have a single 2. So what do I need inside the square root? A couple of 2's, right? So I need a square root of 2 times 2, which is a square root of what? Square root of 4. What's the square root of 4? Ah, there you go, right? So if I had a couple of 2's, I'd be good. So I need to multiply both the top and the bottom by the square root of 2. 2, not 4. If I multiply the top and the bottom by the square root of 4, the square root of 4 is just 2. You guys see that if I multiply 2 times the square root of 2, well, I've got an outside number 2 that stays on the outside and an inside number 2 that stays on the inside. You can't mix outside and inside numbers in a product. I multiply outside numbers by outside numbers and inside numbers by inside numbers. Thank you, Ash. There you go. Okay, makes sense? So we're going to multiply both the top and the bottom by the square root of 2. Okay, how come? Because that's going to give me, on the bottom, that's going to give me a square root of 2 times 2, and that's a couple of 2's, so it goes outside. And I no longer have a square root. Make sense? Okay, what's another way of thinking about that? Well, if I multiply a square root times itself, what am I really doing to something if I multiply it by itself? I'm squaring it. So another way of thinking about this is the square root of 2 squared. Well, if I square a square root, what's that do? Cancels it. They cancel each other out, right? So whichever way you want to think about it, the recipe is the same. We're going to multiply the top and the bottom by the square root of 2, which gives us on the bottom what? 2, exactly. What's it give us on the top? Square root of 6. I've got inside numbers, so they get multiplied, right? And I end up with the square root of 6 on the top, and I'm done. Okay, so how do we know we have to do that? Well, rationalizing denominators, it's the no tenths in the basement rule, meaning you can't have any radicals in the denominator. If you have a radical in the denominator, you've got to do something. Multiply top and bottom by the correct radical to get rid of that radical in the denominator. Okay? Let's try another one. Now, what about this one? What are we going to, we start off with the square root of 48 over 30. Now, first of all, there's a strong temptation to just split that right away and make it the square root of 48 over the square root of 30, which would work, but you're creating a lot of extra work for yourself. What should you probably do first? Right, we want to reduce the fraction because that's easy. That's low-hanging fruit. It's easy to reduce a fraction. You've been doing that for years. So we reduce the fraction to make the numbers inside the radical as small as possible. And once we've done that, then we'll split it up into separate square roots and deal with them individually, right? Does that make sense? So first of all, reduce that fraction, which gives us 8/5 inside the square root, and then we split it into separate square roots, and what's next? Okay, so I heard multiply top and bottom by the square root of 5. That would work, but there's a slightly easier way to do this. We want to always do this the easiest possible way. Math starts to be about doing things efficiently after a while, not just correct, but efficiently. What could I do? The 8? Okay, so right, so I can't just square those because if I square them, I'm going to change the value of the fraction. Ultimately, I am going to multiply by square root of 5 over square root of 5, but what should I do first? Right now, if I multiply by square root of 5 over square root of 5, on the top I'm going to get a square root of 40. I'm starting to get big numbers under the radical. What should I do first? After I split the roots up into separate square roots, I should try to simplify those. I want to get as much out of the radical right away as I can to make the rest of the process easier. Well, with the 5, I'm done. I can't do anything. But what about with the 8? What is the square root of 8 going to simplify to?
2 to the square root.
Hang on.
No. Wait, no.
2 to the square root of
2 square root 2. Now, how'd you get that? You're right.
2. Well, because what we've been doing is like you take the 8 and divide it into like 4 and 2.
There you go.
4 goes into 2.
Okay, good. So we've been doing factor trees, right? And you can always do a factor tree. It's always going to work, but sometimes you can do it a little quicker than a factor tree. So with an 8, we would break that up into a 4 and a 2, and the 4 breaks up into a 2 and a 2. And so you get a couple of 2's and a single 2. So you're going to get an outside 2 and an inside 2, right? Make sense? Factor trees are essential if you're doing really big numbers inside the square root. But if you're doing a square root of 8, you can almost make this a little bit easier. Now I got to put my chart back up now that I'm done S-back testing. But if you look at this chart, these are really important numbers, right? These are perfect squares. We want to see if we can take the radicand and make it a product of a perfect square and then something else. So 8, that's convenient, right? Because 4 is a factor of 8. I could break the 8 up into 4 times 2, couldn't I? Why is that so good? Square root of 4 times square root of 2 is easy because square root of 4 is 2. See the point? So if you can find a perfect square factor of that number, you always split it apart, and that's a really quick and easy way to get the outside number. See what I'm saying? You can always do the factor tree, but you already know that if I do the factor tree, that 4 is a perfect square, and so the square root of 4 is going to give me a 2 because I get a couple of 2's. Okay? So we do that. right? However you want to, factor tree, or you just split that square root of 8 up into square root of 8. I could make square root of 4 times square root of 2, which is just 2 square root of 2, right? That's the quickest and easiest way. Okay, now, finally, now that we've simplified those square roots as much as we can, now we have to rationalize that denominator. So what am I going to multiply top and bottom by? Square root of 5. There you go. Okay, what's that give me on the bottom? 5. You multiply a square root times itself, it's like squaring it, and so I just get a 5. What do I get on the top? What's my outside number going to be? 2. What's my inside number going to be? 10. 2 times the square root of 10. Okay, make sense? Everybody good with that? Okay, do one of these on the board. I want to see it in action, and then we're done with that. We'll talk about it briefly, and I'll let you work. Yeah. Turn you loose and let you work. So what do we do first? Simplify. We're going to reduce that fraction into 7/10, and then I'll split the square roots up. Can I simplify either one of those square roots? No. There are no couples in 10 and no couples in 7, right? No perfect square factors of 10 or 7. So what do I do?
Multiply by square root of 10 on top and bottom.
Good. Multiply top and bottom by the square root of 10. What's that give me on the bottom? 10, right? I'm going to get a couple of 10s inside a square root, so that's an outside 10, or square root of 100, whatever, however you want to think about it. What do I get on top?
70.
Yeah, I'm going to multiply those inside numbers together and get 70, right? Really, we get that 10 from the square root of 100, don't we? Okay, make sense? All right, go to work.